Assalamualaikum and hi everyone.
So today we are going to present to all of you about an interesting topic
Topic 5, which is thermal physics.
under the subject Phi 210.
So let's get going.
About specific heat. What is specific heat? Specific heat is the quantity of heat required to raise the temperature of 1 gram of a substance by 1 Celsius degree. The unit of specific heat are usually calories or joules per gram per Celsius degree. For example, the specific heat of water is 1 calorie or 4.186 joules per gram per Celsius degree. Okay, next, specific heat capacity. Specific heat capacity, or simply specific heat, refer to the heat capacity per unit mass of a pure substance. It is defined as amount of heat need to increase the temperature of 1 kilogram of a material by 1 Kelvin. It is expressed in terms of J per kilogram Kelvin or equally J per kilogram Celsius. As an intensive property, specific heat capacity change with the change in the material's type or phase and can be considered for object of arbitrary size. So, as a life sustain factor on Earth, water has one of the largest specific heat capacity values among all materials, which is 10-fold the specific heat of iron and 5 times that of glass. This means it required 10 times the amount of heat to raise water's temperature the same amount as compared to iron and 5 times the heat as compared to glass. This is a specific heat capacity of some compounds, element and substance. So you can look at the table. Specific heat capacity at constant pressure or volume. Specific heat at constant volume is when the volume remains constant while heat through a short range of temperature and is denoted by symbol CV that stands for constant volume. Meanwhile, specific heat at constant pressure is when the pressure remains constant while heat through a short range of temperature and is denoted by the symbol CP, which means constant pressure.
Moving on, we are going to look at phase change. What is phase change, you may ask? So, phase change is a physical characteristic of the substance that changes from one form to another form. Please take note that there are two common phase changes, which are from solid to liquid, which we call melting, and from liquid to gas, which what we call boiling. Bear in mind for phase change is that during phase change, there is no change in temperature. There is only change in internal energy of the system, and the amount of energy transferred during phase change depends on the amount of substance involved. For example, the melting of an ice cube takes less energy than the melting of a frozen lake. Because as you see, ice cube is very small compared to frozen lake that is way bigger than an ice cube, right? Other than phase change, we are going to look at latent heat, which is the symbol for latent heat is L. Latent heat is the quantity of energy required to change the phase of mass of a substance. So this parameter is called hidden heat because this added or removed energy does result in temperature change. Remember what I mentioned earlier, during phase change, there are no change of temperature, but for latent heat there is a change of temperature because this added or removed energy does result in temperature change. The value of L, which is latent heat, depends on the phase change and the properties of the substance. So the formula that you need to keep in mind is that the energy required to change the phase of a given mass M of a pure substance is Q equal to plus minus ml. Latent heat is divided into two categories, which are latent heat of fusion and latent heat of vaporization. Latent heat of fusion, which is LF, is defined as the heat required to change 1 kilogram of material from solid to liquid. So in other words, latent heat of fusion occurs when there are a melting of an ice. The formula for latent heat of fusion, which is LF, is given by Q, which is heat, divided by mass of the substance. Moving on to the next type of latent heat, which is latent heat of vaporization, which is also we call as LV. So, latent heat of vaporization is defined as the heat required to change 1 kilogram of material from liquid to vapor. So, latent heat of vaporization occurs when there is a boiling of a substance, which the substance will change from liquid into a vapor. The formula given for LV is LV equal to Q, which is heat needed, over mass of the substance, just like latent heat of fission.
Today for my presentation, I'm going to present about the heat transfer mechanism of conduction. Okay, so first thing first is what is conduction? Conduction is the process whereby heat is transferred directly through a material with any bulk motion of the material playing no role in transfer. So it doesn't need the material to like move back and forth or something like that. Okay, so how does it work? So it is a process where heat is transferred through material, and the heat flows from hot to cold until the temperature reaches the thermal equilibrium. So conduction only occurs when the material is in contact with each other. So for example like this. Okay. So we got a hot object and a cold object. So the hot object is at 100 degrees Celsius and the cold object is at 10 degrees Celsius. So the heat transfer here only occurs when the object is in contact with each other like this. And the heat flow is only from the hot region to cold region. During the thermal equilibrium, the net flow is zero. Heat conducted per second depends on the length and cross-sectional area of the bars, as well as the temperature of each end. And we got the formula here, which is the Q over T equals to K over A, Ka, and T1 minus T2 over L. I'm going to talk about the conductors and insulators. So during the heat conduction, it also depends on the material of the object. So for conductors, it's a material that allows energy in the form of heat to be transferred within the material. That's for example like silver, copper, aluminum, and steel, as you see here. It is a good conductor of heat. And insulators, a material that is poor conductor as of heat. And you can see that we got ice, glass, brick, concrete, water, and human tissue, which is a bad conductor of heat. This value here is a thermal conductivity of the material, and it's labeled as K.
Here is the heat transfer mechanism for convection. What is heat convection? It is the transfer of thermal energy by the physical movement of fluid, liquid, gas, or plasma from one location to another. What causes convection? It happens when particles with a lot of heat energy in a liquid or gas move and take the place of particles with less heat energy. Convection current is when transfer heat from one place to another by mass motion of a fluid. Here are the examples for the convection process in daily life, which are breeze, boiling water, blood circulation in warm-blooded mammals, air conditioner, and refrigerator. Convection current causes when a liquid or gas is heated. The particles move faster. As the particles move faster, they spread apart. Because the particles of the heat fluid are farther apart, they occupy more space. The density decreases, but when a fluid cools, its particles move more slowly and settle together more closely. As the fluid becomes cooler, its density increases. The formula for convection heat is Q equals to H, A delta T. Q is the heat transfer, H is the convection heat transfer coefficient, A is the exposed surface area, and delta T is the temperature differences. Next is the heat transfer mechanism for radiation. What is radiation? A process where heat waves are emitted that may be absorbed, reflected, or transmitted through a colder body. How is heat radiation produced? Thermal radiation is generated when heat from the movement of charges in the material, electrons and protons in common forms of matter, is converted to electromagnetic radiation. Examples in our daily life such as ultraviolet light from the sun, heat from a stove burner, visible light from a candle, X-rays from an X-ray machine, alpha particles emitted from the radioactive decay of uranium, sound waves from your stereo.
We have come to the end of our presentation. We are highly motivated
To Madam Fatimah, who teach us with exceptional professionalism.
So with that, thank you and goodbye. Assalamualaikum.